Hello friends, welcome to Susan and John MathTube. This is lesson number 19 and this will be the last lesson in improper integrals. And in this lesson, we will work out a few miscellaneous problems, that is problems of different types, but it is connected to the past lessons. Okay, so the 5 important points. Okay, let's start. So it's a short video, so please write question number 1. And once more I'll warn you, if you have not watched lesson number 18, you may not understand anything which we do in lesson number 19. So if you're watching lesson number 19 without watching lesson number 18, please pause the video right now and check out lesson number 18. So please note the first question. Integral 0 to pi sin x by cos square x dx. Okay, this looks like a very simple integral. Of course, it's a simple integral because it is just symbol substitution method. But it's extremely connected with the problem which we did in the last lesson. And the method is so simple, even a class 12 student can give us a hint. Put cos x is equal to t. The reason is very simple, because if you put cos x equal to t, you will get sin x to be the derivative. Okay, I hope you remember the two things which you are supposed to do after substitution. One is the differential. So minus sin x dx is equal to dt. And that gives me sin x dx equal to minus dt. So I'll put it in a box. So we are ready for the substitution here. And we are ready for this also. Now the most important thing, the given limit, the given variable is x. So that means these limits belong to x. But the new character is t. So we want the values of t. And for that you read from right to left. That is exactly what I'm going to write here. T equal to cos x. Now look at this. If x equal to, look at the given integral. If x is equal to the lower limit, t will be cos 0, that is 1. Now if x is the upper limit, what's the upper limit? Pi. T will be cos pi. And what is cos pi? Minus 1. That's it. That's it. And you're going to see someone you saw in the last video. So we get I equal to integral. Look at this. Instead of 0 I had to put 1, and instead of pi I had to put minus 1. So I'm going to write t is equal to 1 to minus 1, and this will be 1 by t square, and the remaining part will be minus dt. Now look at this. I'm going to flip the limits. If I flip the limits, the upper limit will be here and the lower limit will be here, and the penalty is 1 minus. When you interchange the limit, what will happen to the value? It will be negative. And that negative and this negative will give me positive. So the remaining is 1 by t square dt. And in the next line, I'm going to write something which most of you may have some objection if you are not watching all the videos regularly. Look at this. I'll give you a few examples. We have discussed this in lesson 13 or somewhere. I don't remember now. Anyway, what is integral 1 to 2 x square dx? What about integral 1 to 2 y square dy? What about integral 1 to 2 t square dt? You try to do these three problems, you will understand why in a definite integral the variable does not matter. You can use any variable you like, but you're not allowed to change the limit. You're not allowed to change the function. Check it yourself. Okay, now I'm going to stop with this because I told you this is just a miscellaneous lesson. And now I want you to take a look at lesson number 18. That's it. Okay, so do the remaining part by yourself, or you can refer lesson number 18 and find the answer by yourself. Okay, now look at this. Another very important question which I have seen in some examinations. integral 0 to 2 dx the whole divided by 1 minus x the whole square. Okay, here also the question is of very basic level because I can see that the derivative of x is 1. So what I do is, like before, I am going to put 1 minus x equal to t. And remember, once you substitute, you have to think about two things. One is the differential, and the differential of 1 is 0 and x is dx. Okay, so we get minus dx equal to dt. By the way, I am not interested in minus dx, I want dx, so dx is equal to minus dt, which I'll keep in a box. Okay, on this side, look at this. This limit belongs to x, but the new person is t, so I'm going to read from right to left. So t is equal to 1 minus x. If x is equal to 0, then t will be 1 minus 0, that is 1. If x is equal to the upper limit, then t will be 1 minus 2, that is equal to minus 1. Okay, time to substitute everything. I'll give this integral a name. What are the new limits? 1, 2, minus 1. And this is minus dt by t square. Okay, in the next line, I'm going to flip the limits. So 1 by t square dt. When I flip the limits, there will be negative, negative of negative will be positive. So we end up like this. And just now, just 2 minutes back, we discussed in a definite interval, the variables do not matter. Oh, we get the same thing. We get the same thing. And those students who went through all the problems in lesson number 18 or will feel very easy to evaluate it. If you have not watched lesson 18, please watch lesson 18 and find the answer. Okay, now I'll give you 2 more miscellaneous questions. Another question is like root under a minus x by x. If you ask me whether it's improper, my answer will be yes, it is improper. Now, it's not type 1 for sure, because type 1 I told you the upper limit or the lower limit will be infinity. So I checked for type 2 by substituting the endpoints, and I can see that 0 is a villain. But this problem can be dealt cunningly by putting x is equal to a sine square theta. I'm sure that you know if you have root under 1 minus x square, sine theta will help you. If you have root under a square minus x square, a sine theta will help you. Similarly, when you have a minus x, I put a sine square theta so that a will come common and we will have cos theta. So you keep this substitution, and this means dx is equal to a into, do you know how to differentiate sine theta the whole square? Yeah, 2 times sine theta into cos theta d theta. And sine square theta equal to x by a. So sine theta is equal to root under x by a. So theta equal to sine inverse x by a. So that when you put lower limit for x, so when x equal to 0, theta is equal to 0. And when x equal to a, theta will be pi by 2. And I think that is more than enough. Please to try the problem right now. And in case you have any difficulty, you can ask me in the comment box below. Now the last problem in this lesson and in improper integral, which I wanted to share with you, is 0 to 1 root under 1 plus x by 1 minus x. Again, I am telling you, whether you ask me it is compulsory to use improper integral here, no. Here also you will be saved by a substitution. Look at this. Whenever you have 1 plus x and 1 minus x, you should remember the formula 1 plus cos 2 theta and 1 minus cos 2 theta, so that you will be able to do this problem very easily. The method is very easy. Put x is equal to cos 2 theta. So that 2 theta is equal to cos inverse x. So theta will be 1 by 2 cos inverse x. And when x equal to 0, theta is equal to 1 by 2 cos inverse 0. And when x equal to 1, theta is equal to 1 by 2 cos inverse 1, that is 0, is equal to 0. So use these facts, try the question and tell me whether you are able to work out the question very easily or not. Wait a minute, I think I need to give you one more hint. Dx. Can you take the differential of this? Yeah, minus 2 sine 2 theta. And immediately simplify 2 into, do you know what is sine 2 theta? 2 sine theta cos theta. Oops, I forgot d theta, so d theta. Okay, so I'm going to wind up this video right now. You have to work out the 4 questions now itself, and if you feel any difficulty, feel free to email me, or you can contact me through messenger in my website. Anyway, I'll be back with another lesson, and the next lesson is differentiation under the integral sign. That's a very important topic. Anyway, in lesson number 20, what we do is we learn partial differentiation. Look at this. Partial differentiation is very important if you want to solve or if you want to apply Leibniz rule in differentiation under the integral sign. So that is exactly what we are going to do. We are going to make our partial differentiation strong. I mean the basic part very strong, and then try to work out a lot of questions in differentiation under integral sign. So I'll be back soon. So till then, bye.